Hello students, today we are going to discuss our one more complex topic, that is searching. So as we all know that searching is very much required in the field of computer science, as every time we want to search or we want to find some data. So searching is a process of finding a particular element among several given elements. So here we have a list of elements and we have to find a particular element as per the requirement of the user. So a search is successful when we found the data, and search is unsuccessful when we do not find the data. So this is the example how we are going to search the element. If suppose this is the list of element we are having here. So here we have number of elements written, that is 25, 10, 20, 15, 17 and so on. So successful search and unsuccessful search are the example. If we are looking for the element 15, we can see that 15 is present at third index, which means search is successful, position at 3. But if we are looking for the data, that is 40, it is not present within the list. So our search is unsuccessful. So in this way we can see that the required data is either search is successful or not. Now, why do we need searching? Searching is one of the core concept within the computer science. We know we have lot of information, we have lot of data, but each and every data is not required by the user. Only particular data set is required at a time. So whenever we want to retrieve some particular information from the whole data set, we need the searching. Types of searching, we have two types of searching, that is sequential search and interval search. Sequential search means in this number of elements are sequentially searched. For example, we have linear search. And in interval search, the data is divided into parts, and within those parts we look for the particular element. The example is binary search. So broadly we can classify that we have two types of searching techniques, that is linear search and binary search. One by one we are going to discuss these two kinds of searches. So first of all we will discuss the linear search. Linear search, it is one of the simplest and easy technique in which user has to insert the data and he has to compare each and every element one by one, that is in a sequence. So linear search, it is the simplest technique and it traverses the array sequentially to locate the required element. So whenever we provide data, we input data within the system. The system is supposed to search for the element one by one, comparing each and every element which is present within the list. For example, if we have set of elements like this 10, 50, 30, 70, 80, 60, 20, 90 and 40. So now here we want to find out 20. We have to search for data 20. So how we are going to search using linear search? First of all, 20 is compared with 10. It is not equal. Next, it is compared with 50. Next with 30. Next 70, 80, 60 and then 20. Data matches. So what is the technique we are following here? We are comparing each and every element one by one, starting from the very first element and looking for the data which is required. As we are looking for the 20, we are comparing each and every element in a proper sequence. So what linear search says? In linear search, each and every element of array is compared sequentially, and when we have a match of data, search is successful. But if we reach the last of the array or the list of element and there is no match, it means search is unsuccessful. Just take another example here. If we have input array this and we want to search 110. So how we are going to compare? 110 is compared with 10 first. It is not matching. Next element is 20, next 80, 30, 60, 50. Next we have 110. Yes, search is successful. We found the required element. So, at which position 110 is present? 1, 2, 3, 4, 5, 6. That is at 6th position, index 6, we are having the data 110. Now, let us take another example, that is 175. So, can we find 175 within the array? Again, the strategy will remain same. That is, we are going to compare each and every element sequentially, one by one. So, first of all, it is compared with 10. Next, 20, 80, 30, 60, 50, 110, 100, 130, 170. We reached to the end of the list, but didn't found the element 175, which means search is unsuccessful. The element is not present within the list. So, this is the algorithm for the linear search. In this particular algorithm, what we are doing? We are iterating from 0 to n minus 1 steps. 0 to n minus 1, what we have to do? We have to compare each and every element of array. So, starting from the leftmost element of array and one by one comparing x with each element of array. If matches, x matches with the element, return the index value. But if does not match, then return -1, or you can say the search is unsuccessful. So, we can also write this in computational way like this. It is assumed t is equals to 0, then for I is equals to 0 to less than n means how many steps? 0 to n minus 1. What we are doing? We are comparing the num. Num is what? It is the required element which is to be searched by the user. So, num is equals to AI. AI is what? It is the array in which element is being searched. So, number is compared with each and every element of array. Now, if this condition, if condition is true, means if number matches, t will become 1 and loop will break here. Here we can see the program of linear search. What we have taken? We have taken an array of 50 elements. Next, we are taking the size of element, size of array from the user. Let us assume the size which is entered by user is 5. Now, for inserting the elements, we are scanning the elements within the array. So, we are taking the for loop for I is equals to 0, I is less than n, I plus plus. What we are doing? We are scanning the elements. We are taking input from the user side and storing it within the array AI. Now, the element which is to be searched is being stored in M. It is the element which is to be searched. Now, this is the logic part, what we have discussed before in the algorithm. That is for I is equals to 0 to less than n. What we are doing? We are comparing the element, that is M, which is the element which is to be searched, with the each and every element of array. Here t is equals to 1 and p is equals to I. T is what? It is just a variable which is holding the position, which is changing its value to 1, as we have initialized t with 0. And what is p? It is storing the index value within it, so that at the end we can print the position of the element. Now, when search is successful, means when we found the element within the array, what we will do? We will come out of the loop. There is no need to search, look for the element in the further list. So, we break, that is, we come out of the loop. Now, if t is equals to 1, element is found at position p. Okay, means if the value of t is set to 1, element is found and position is stored within the p variable. We have written p is equals to I, so whatever is the index value is stored in p and search is successful. That is why the value of p is printed. But if t is not set to 1, means T will remain as it is, that is equal to 0, what we have initialized in at starting, then it means search is unsuccessful. So what it will print? Element not found. So what is going to be the output? Let us assume the size is what? It is 6. Elements entered by user are 8, 6, 25, 4, 15 and 7. Now what element user want to search? User wants to search 15. So 15 is present at position 4, that is 0, 1, 2, 3, 4, 5. That is index of array always starts from 0. So at which position element is found? Element is found at 4th position. So here we have the time complexity. So for linear search, in the best case, time complexity is O of 1. That is, the first element is going to be the required data. Otherwise, in worst case, when we didn't found the element, in that particular case, number of operations performed are n, because there are n numbers present within the list and each and every element is compared at least once. So the time complexity exceeds to O of n operations. Next we have binary search. So binary search, when it is compared with the linear search, binary search is one of the fastest technique as when it is compared with linear search. Why it is fast? Because it works on the concept of divide and conquer. It firstly divides the data into 2 halves and then search for the data in 1 half only. Again, if data is not found, then that particular first half is going to be further divided into 2 halves and then data is being searched. Means instead of comparing each and every element sequentially, what we are doing in the linear search, binary search divides the list into multiple parts and data is searched within those single parts, not in the complete list of element. But for process of this searching, it is mandatory that your data should be in sorted order. If your data is not in sorted order, you cannot implement the binary search. So mandatory condition for binary search is that you have to sort your, or you can say arrange your data in a particular order, either ascending or descending. For example, if we have a list of element this, that is 2, 5, 8, 12, 16, 23, 38, 56, 72 and 91. So what is the process for binary search? Binary search always compares with the middle element and then divide the list into 2 equal halves. So for example, if element which is to be searched is 23, we want to search for 23. In this particular case, first of all, find out the middle element within the list. So what is going to be the middle element? What is the formula to calculate the middle element, middle position? As we all know, array starts from 0th index. So how many elements are there? We have 0 to 9. So position of lower bound of array is 0 and upper bound is 9. So 0 plus 9 divided by 2, that is 4.5. Clear? It means, and in C, we always compare these index values as integer part. So only integer part is taken. So 4.5 integer part is 4 only. So what is the middle position? Middle position is 4. So it means this, where 16 is stored at index 4 is the middle element. Now middle element is compared with 23. What is the relationship between 16 and 23? 23 is greater than 16, which means 23 must be present to the right side of 16. Means what we have to do? We have to look for 23 in the right half of the list. So from here, the list will get divided into 2 parts, left half and right half, or you can say first half or second half. And what is the position of 23 as compared to 16? 23 must be present in the second half of the list. So we will now look for 23 in the second half of the list. Now same process is again repeated to the second half of the list. So now here we have 23, 38, 56, 72 and 91. Now as we are shifting towards the one half of the list, now some positions are being changed. As you can see that upper bound of array is not changed. It is being fixed, that is 9. But now first element of the list is going to be the element which is present at index 5, which means lower bound is updated. So lower bound is updated as mid plus 1. What is the value of mid? Previously mid is 4. Now plus 1, that is 5. Next element which is present to middle element is going to be the new lower bound of the array. So with the help of this formula we can calculate the lower bound of the array. So now lower bound of array is 5 and upper bound is same, that is 9. Again repeat the process, means again we are going to calculate the middle element. Middle element again lower bound plus upper bound divide by 2. Lower bound is what? 5 and upper bound is 9 divided by 2, that is 14 by 2, or you can say 7. So it means now middle element is 56. Now compare 23 with 56. So when we compare 23 with 56, we can say 23 is less than 56. Okay? We can say that 23 is less than 56. So again list is going to be further divided into two parts, first half and second half. And as 23 is smaller than 56, it means we have to search 23 within the first half of the list this time. So first half of the list, as we are moving towards the first half of the list, lower bound will remain same but upper bound will change. So now what is the upper bound now? That is 6, a position which is 1 less than the middle. So now we can say upper bound is middle minus 1. So middle is what? 7. 7 minus 1, 6. So upper bound is calculated as 6. Now again we are going to calculate the middle element. Middle element is what? Lower bound plus upper bound. Lower bound is what? 5 and upper bound is 6. So 5 plus 6, that is 5 plus 6, that is 11 by 2, or you can say 5.5, which means if we are going to take only integer part, it is 5. So middle element is what? 23. Now compare 23, that is the required element, with the middle one. So required element is found, that is 23 matches with the middle element of the list. So here we found the element at position 5, or you can say index value 5. So total how many comparisons, or in how many steps you found the element 23? We can say we can have the result within the 3 steps. But if we are using linear search, in how many steps we are going to find the element? First of all, element 2 is compared, that is first step. Then 5 is compared, 8 is compared, 12, 16 and then 23. Means total how many steps are required to get the search successful? 1, 2, 3, 4, 5 and 6. Means after comparing 6 elements, we found the element while we are using the linear search. But after 3 steps only, we found the result when we are using binary search, which means binary search is faster as compared to the linear search. But only constraint with the binary search is that the data should be in sorted order. It must be arranged in proper order, either ascending or descending. If data is not sorted in that particular case, it must be sorted first. After that, searching can be implemented. But in case of linear search, there is no condition that data must be sorted. We can take data in any order, in any random order. So the only constraint with binary search is that the data must be in sorted order. So binary search is a searching algorithm used in sorted array by repeatedly dividing the search interval in halves. So this is the main logic or main idea behind the binary search. So here we can see the algorithm for the binary search. As written, that binary search, what we have taken, array, size of middle element, low and high. Low and high are the lower bound and upper bound. So for how long we are going to conduct the binary search? Till the condition when lower is high, return false, means when a situation arises that lower bound of array is increasing than the upper bound of array. In that particular case, we have to stop our algorithm. Otherwise, each and every time we have to find the middle element. And what is the formula for the middle element? It is low plus high, that is lower bound plus upper bound divided by 2. Now this middle element is being compared with the required element. Required element is what? X. So each and every time middle element is only compared with the required element. If search is successful, it will return the mid. Otherwise, it is being compared whether the required element, that is X, is greater than the middle element or smaller than the middle element. If X is greater than the middle element, in that particular case, what we will do? We will update the lower bound of the array. What is the formula for updating the lower bound? That is middle plus 1. So lower bound of array is updated as mid plus 1 and upper bound will remain same. Again middle value is being calculated and then searched. Otherwise, if X is on the left side, or you can say if the required element is smaller than the middle element, in that particular case, upper bound is updated as mid minus 1. So now let us discuss the program for binary search. So what we have taken? We have again taken the values here, declared the array, I for looping, first that is for the lower bound, last is for the upper bound, middle for the middle value, S that is the size of array, and N is the required element which is to be searched. Now, first of all, we are taking the size of array from the user. So, let us assume size of array which is inserted by user is stored in S. Now, enter the elements within S. So, we have taken the loop I is equals to 0, I is less than S. S is what? It is the size which is entered by the user. Now, scan with the help of scanf function, we are taking input within the array AI. Now, element which is to be searched is N. So, N is the number which is being searched by the user. So, initially lower bound of array is what? It is always 0. So, first is 0 and last, that is upper bound, is what? Size minus 1, that is S minus 1. Now, while first is less than equal to last, means list of element exists. This is the condition to check whether the list of element exists or not. For example, if I say that number of elements which are being entered by users are 7, value of S is 7. And now let us take the elements 10, 20, 30, 40, 50, 60 and 70. Total 7 elements are being taken by the user. Now, till here we have taken the input. What is the position? Means lower bound and upper bound of array, that is 0, 1, 2, 3, 4, 5 and 6. Now it is clear that first is equals to 0 and last is equals to s minus 1. What is the size being entered by the user? It is 7 and the upper bound value is s minus 1, that is 6. So condition is checked first of all, that is while first must be less than equal to last. Means certain list of element must exist within the system so that data can be searched. If the list is not present, then in that case how we are going to search the data? So first of all condition is checked, that is first, that is lower bound must be less than equal to upper bound. So here we have true condition, that is 0 is less than 6. Now middle is equals to first plus last by 2. What is the value of first? It is 0. And what is the value of last? It is 6. So 0 plus 6 by 2, that is 3. So middle position is 40. Now let us assume we want to look for 10. Value of n is 10. So 40, it is compared with 10. What is the situation? If a middle is less than n, a mid is what? A mid is 40. So 40 is less than n. N is what? 10. Condition is false, which means we will go for the else if condition. Else if says if a middle is greater than n. Yes, it is true. N is 10 and a middle is 40, which means this particular condition is true, which says last is equals to middle minus 1, which means upper bound of array is being modified to the position 1 less than the middle. So upper bound, that is last, will become middle minus 1, that is middle is what? 3. 3 minus 1, that is 2. So now last is equals to 2. So here we updated upper bound as 2. Again check. Again condition will go for the previous one, while first is less than equal to last. Yes, it is true. First is 0 and last is 2. Condition is true. So again we will enter into the loop. Calculate the middle. Middle is what? First plus last by 2. First is what? 0. Last is 2 by 2, that is 1. Means now middle element is 20. Again condition is there, if a middle is less than n, condition is false. So we will go for else if a middle is greater than n. Yes, it is true, because 20 is greater than 10. So again last is updated, that is last will become middle minus 1. So middle minus 1, that is 1 minus 1, 0. So again last is what? This only. So now we have last as well as first at 0th index. So still condition is true. First is less than equal to last. So we will enter within the loop. Middle is equals to first plus last by 2, that is 0 plus 0 by 2, that will become 0. Means now this particular element is middle element. So now compare. This condition will become false. This will become false. Else condition, element is found at percentile D position, middle. Middle position क्या है आपकी? 0. So we are getting the value at 0th position. Now we will break the loop and come outside the loop. So, but if element is not found, if first is greater than last, in that particular case search is unsuccessful. So I hope the concept is clear. What is linear search and binary search? in exams many times question comes which is the better algorithm. So you can easily explain the concept with the help of example. That's all for the day. Thank you.